Okay, this is a little homework example, a couple of homework example problems for doing chapter 2 on the conceptual physics, um, uh, out of the conceptual physics textbook. Uh, these are the ones I thought might give a little bit of trouble, but so I wanted to review them. These are you'll see these numbered once you get access to the ebook, or if you happen to rent the physical book, you'll see these numbers corresponding to what's in the text. The first one is just a word problem. It says, "What is the?" I think I can dismiss my image here. Let's. All right. What is the resultant of a pair of 1 Newton forces at right angles to each other? Okay, this is going to be a trigonometry problem. So we have the resultant squared. This is just Pythagorean theorem. The resultant squared is equal to the vertical component squared plus the horizontal component squared. Now, these two forces could have been at any right angle one to another. They could have been like this. I just chose to do them on a grid like this, one horizontal, one vertical. I am reading a bit more into the problem than is stated, but I have a point for doing that. So the resultant squared is equal to the vertical component squared plus the horizontal component squared. So in order to get the resultant, you do that addition, and then you get the square root to get the resultant. So the resultant squared in this case is equal to the vertical squared, which is 1 squared, plus the horizontal. Oops, jumped the gun. 1 squared. So that's equal to r squared is equal to 2. So r is equal to the square root of 2, which is equal to 1.414. And that would be the answer to this problem. Now, it doesn't ask for it here in this problem, but in order to help you with other problems, I'm going to ask, well, oh, so what does that look like? Well, let's do the parallelogram method. Let's copy that and paste it, and we'll paste. Oh, let's paste that again, and there, using the parallelogram method, we're going to, let me change colors just so we'll see the resultant will stand out. There is the resultant. And you can see it's longer than 1. And if the resultant is 1.414, the square root of 2. Now, it's not asking for the angle, but if I wanted to know what this angle theta was, which another problem does ask for the direction, the way to get the angle theta, let's switch back to blue. The theta is equal to the inverse tangent of the vertical over the horizontal. So what does that look like? That looks like tangent inverse, which is also called arc tangent, tangent inverse of 1 over 1. So the inverse tangent of 1 is equal to 45 degrees. So this angle is 45 degrees. Now, it doesn't ask that for that in this problem, but in another problem it does. Now, in order to know that whenever you like put in your calculator the inverse tangent of uh, uh, inverse tangent of a pair, the calculator is not going to know which one's on which one uh, is your y and which one is your x. It's just going to come out with a ratio. So when I was in high school, we had this little um, trick. At the time, our via transit system was called San Antonio Transit Company, San Antonio Transit Company, and that would tell you um, what what are what angles, what was positive and what was negative. Here, the A stands for all, so the sine, the cosine, and the tangent are all positive. All of these are positive. Uh, in this quadrant, the S, only the sine is positive. The cosine is negative and the tangent is negative. Sorry for the barking dogs. In this quadrant, only the tangent, let me capitalize that. Only the tangent is positive. And in this quadrant, only the cosine is positive. San Antonio Transit Company, sine, all, tangent, and cosine. That's a little trick. I'll go through that more if I do a trigonometry review. Okay, I think that's enough about that particular problem. Let's go on with this next problem. A 400 Newton scaffold supports two painters. One 500 newtons and the other 400 newtons. The reading on the left scale is 800 newtons. What is the reading in the right hand scale? Now, well, what do we know? If it's in equilibrium, and it indicates that it's in equilibrium, it's standing still, we know that when it's standing still, the sum of all the forces has to equal 0. Well, let's get the forces, the sum of the forces. Let's do the downward forces. We have 500 newtons plus 400 newtons for the plank plus 400 newtons for the other worker. And you know what? I guess let me change that. I'm going to make those negative since they're all downward. So let's zip through that, and let's say minus 500 newtons minus 400 newtons minus 400 newtons plus 800 newtons. So the sum of the forces is equal to, what do we have here? We have 8 and 5. We have a negative 1,300 and and then we have an unknown plus the unknown newtons. Okay, so minus 1,300 plus 800 newtons plus the unknown newtons. Well, this comes out to minus 500 plus the unknown newtons. So to balance this out, we add 500 to each side. So 500 newtons equals the unknown newtons, the unknown weight. So the answer is 500 newtons. Okay. All right. Let me square this one up here. This is the answer to the previous one. Okay. And so here are a couple of sample problems. Just wanted to give those to you. Now I'm going to end. I will probably do a trigonometry review if it's asked for, and That's it for this lecture.